My name is Jakub Rojek. I'm a co-founder of TokenGuard. In TokenGuard, we are delivering insights about blockchain users to application creators, the app creators, and ecosystems, so they can understand behaviors of their users and better target what should they do next, in which direction their app should develop, what users like, what features they don't use, and it's not worth investing any more money into it. We have created an application in which we are tracking most common ecosystems along with Aleph0, of course. And we calculate the synthetic measure on how can we judge whether the chain is growing or if it is not growing. We take into account several metrics like active users, TVL transactions, stuff like this. And this is the first step in discovering what blockchains are and what are not. And the next step is doing the same for applications. So you could track how your application develops and what to do, what are the users doing within your application, and compare it to your competition. Behind the scenes in our application, we have subsquid indexers, many of them. And subsquid is a company that indexes a lot of EVM-based and non-EV substrate-based blockchains. And they provide developers with the interface to create their own indexers, which will just index the data they need for their application. They have great tutorials on the internet on how to quickly create and set up your squid. And today I just wanted to show you how this can work. And I'm happy to see other ID representative here because I wanted to create a squid based on other ID registry. Right. Let me just jump straight into the code, I guess. So I will keep this tutorial around, so it will also help me. But the idea here is that the subsquid team created the template for how to interact with the blockchains or with their archives, because they have a middle layer from. We don't index the data directly from the node, but we partially index the data from the already indexed SQL databases that they host. So the first step is to create the repository from their template, and then install the dependencies and build the squid. So let me just copy this. I already created the template. So what I'm going to do now is just open my terminal and paste the commands here. So it will install the dependencies and build the basic layer for my squid indexer. And a lot of things we do here are automated, or the code is generated thanks to the Squid SDK. So you will see that what I need to do is really just little adjustments, and I can jump straight into what I really want to achieve. when we are talking about subscripts, the main interface here is GraphQL. GraphQL interface, or we can access the data through GraphQL. So first thing we need to do, okay, the sanity check passed, so my my processor started, and it created some tables in my database already, but these are not the tables that I'm about to use because they base on some different contract. But going back to this, first the interface is GraphQL, and I need to define the tables that are interesting to me. This is for regular ERC20 token, but since we're talking about custom contract, Azure ID registry, we can go ahead and go to Azure ID page, and there they listed contracts that that create their application. And the most important one here is the registry itself. The registry itself resides on this address on the mainnet. Oh no, this one. And the team shared metadata, so the ABIs of their contracts, so I could download them, and then I can open the metadata, and I can also open some helpful information about the contract also, which is also provided. So here is the API. We're not going to dive deep into what it is, but I'm just going to copy it to my code. And here, let's create, come on, new directory, call it API. And this is API for one single contract called registry. JSON. Okay. We have all the extrinsics, constructors and stuff like this here, obviously, but what is important or interesting to me today for just the sake of the example is not constructors, not the environment, but the events. So there are several events in the contract defined, obviously, but we're going to focus on the register event, which is emitted whenever a new name is registered. As we can see, this register event has 4 parameters. First one is name of the registry. The other one is account ID of the owner, or the registry, registration timestamp and expiration timestamp. So keeping this in mind, I will start creating my my GraphQL schema. So let's say I will need my owner and the domain itself. So type owner. And it will have ID. And also type domain. It will also have its own ID, which will be the name of the registry. The domain obviously has owner, which will be of type owner. Can also index, add index for this field. We also have registration timestamp and expiration timestamp. But we want to keep it in a human readable form. So let's make it a date, registration date, date time, and expiration date time. All right. So by this definition, we will know which domain has which owner. It might also be interesting for us to see what domains the owner has. So for the syntactic sugar of GraphQL, I can also add the reference here that user has domains, but this will be just a list of domain derived from field owner in the table domain. Okay. So this is my GraphQL interface to discover what domains are owned by whom in a very naive fashion, because the domains can also change. The owner of the domain can change, but for the simplicity, let's keep it here. And now we go back to the terminal. And it is also obviously written in the tutorial that when we end defining our schema, we execute command CodeGen, which will generate types from our schema, so we can use it in our code. And they are here. So we can now see that I created domain model, and it has a relationship to owner plus two fields. Similar thing is here, that I have my owner and the relation to domains. So this is what this SQD CodeGen command generated for me, so I can use the classes in my code. And then the next thing is we need to make some type definitions about the ABI that this contract is about. So we can reference that in the code. Again, Squid has very cool tool to do exactly that. It is called ink typegen. And then I can, when it installs, I can generate types from directly from my ABI. Okay. Let me just change this to registry. And this also to registry. So I will generate types from the ABI file, JSON file in my ABI registry directory, and output it to as source ABI registry TypeScript. Okay, and now we have it. So we can see that here we have the copy of the ABI, but we also have a lot of functions which we can use in our code. For this example, we will just decode events. So we will use just this function, and the event itself is called register. It is labeled register, and I also have the subscript generated an interface for that event as well. So you can see that it has fields kind register, and the fields that I defined that are defined in the API. So now, after this preparation, I'm ready to jump into the processing the data itself. So the template actually contains so the next file we look at is setting up our processor. So we need to inform it from where to pick the data, and for us, this will be the archives are defined in one of the repositories of Subsquid. For Aleph0, it is Aleph0, and it is the newest ArrowSquid release. And if we need to connect to node, then we also need to provide RPC endpoint for the node. Here it is Kusama, but what we will use will be A0dev. All right. We won't actually need RPC endpoint, so we can as well just remove that. And in our processor, we set the data source, and then we filter information about what is interesting to us. So for me, the interesting event is the one emitted by contract. And here in the tutorial, we can see this as well. That's to filter the data about the events emitted by the contract, we have following structure. And then we can filter the data set that we will obtain from the data source. Because in indexers, it is super important to have as little data as possible to process that data as fast as possible. So actually, I won't need extrinsics for my example, but let me just copy this. Okay. So I'm looking for events emitted by contract. My contract address, let's define it here, but it will be actually a little tricky because I need to set out the prefix for the network. Aleph0 network uses the prefix which is defined in Subsquid just as substrate prefix. And then I need to define my contract address, which I can take as 58. Okay, which I can take from this file. All right. And then I need to convert that address to hexes because this is what Subsquid operates on, basically. Contract address. And it will be SS58 codec SS network. Decode. Contract address SS58. All right. I'm missing SS58. Import 58 from Subsquid SS58. All right. So now I have set my data source and said that I want to filter only events emitted by my contract. I can also change starting block to the block on which the contract was actually deployed, because it doesn't make sense to process all the data if the contract didn't even exist there. Okay, and the rest I believe can stay the same. So this defines my data source. I want to pull information from Aleph0 database and technically possibly also from RPC node of Aleph0. I'm interested in events emitted by my contract and very little amount of data about the blocks. And the next thing, and pretty much last as well, is defining the processor itself. So when the processor of Squid is running, it is it delivers blocks in batches. It is hidden in this CTX or context variable. Let me just remove what was here from the example, and we will create my own processor. So first of all, we need to import stuff that we generated. So my ABI types are in the registry. So import as registry from ABI registry. Okay. And also my generated types. These were generated the SQL models, GraphQL models generated. So what I created was domain and owner, right? I won't need types events, I believe, but let's leave it for now here. So in context, I receive blocks, so I will just iterate const block of blocks. And in every block, I have extrinsics, I have messages, and I have events. So I will iterate through all the events that I received for const event of block events. And then I need to find out if the event that I received is actually what I'm looking for. So if event name equals events from the palette contract emitted, and if it is emitted by my my contract instance event event args contract. If it equals my contract address. And if it does, then I can move on to processing that event. When I know that it is emitted by my contract, I can now be sure that I can decode it because I have provided the API. So let's decode the event. Equals registry. So my API decode event. It is a function which was generated for me at the very beginning, decode event. And I just pass event args data. Okay. And with that decoded event, I can check if this is the event that I'm looking for. So I'm looking for an event register. It was here, event register. So event if event decoded dot kind equals register. And I'm sure that at this point I'm in my event. So now what I need to do is to extract the owner and extract the domain from that event properties. But given the fact that we're running out of time, let me maybe just give me a second. I will copy the code from the repository already. So if I have my decoded event register, oh. Okay. And here. All right, I also need to define my network or import it from the processor. Contract address SS58 network. All right. So in this part of the code where I'm extracting the information about the contract, I'm interested in unique owners from all the whole batch contains n owners, but there can be duplicates. So I'm creating a unique list. I'm decoding the event decoded from, so this field here, decoding it to SS58 format and adding it to my list. And for the domains, the domain can only be registered once, so I can just push directly to the list of my type domains. So I'm creating the new one and just mapping the fields. So the ID will be the event name. My owner is what we have in event decoded from. And my registration date is registration timestamp, expiration is expiration timestamp. Here we have numbers, and I want to store dates, so I have to map this accordingly. And if all my ifs are correct, that at this point in time, I should end up with the list of unique owners and domains, which I can then push to my database. It is important to remember that we should only insert data once, not with every iteration, because these are very expensive database operations. So it's better to do this in batches. One last thing that I need to do here is to map this unique list of owners to actual objects of my owner type. So owner has just one field ID, so it's pretty simple. And then I can insert the domains and upsert the owners, because in previous batch there could be owners that already existed here. So I want to just do the upsert. And for the domains, I'm doing insert. And this pretty much concludes the operation of mapping the subsquid processor, or creating the subsquid processor, which maps events from other ID registry. So let's go back to the tutorial and test if I succeeded. So let's generate the schema. because here I have my old schema for the transfer, and it is not useful right now. So let's bring the squid down and migrate the data again. Okay, something is running. Let's kill it. Again. And if the migration ends correctly, I should be able to start my brand new squid. So let's just see if the migration. Okay, so I have table domain, table owner, and I should be ready to process data. So I'm just running sqd process. And let's see what happens. The migration applied correctly. Okay, the RPC endpoint doesn't respond. Okay, let's see what happens if I comment this out. That's interesting. What am I missing? Acer dev, this is the endpoint that I've been using so far. Okay. That's unfortunate. Let's see. Can I just change? So, what if we try HTTPS here, but I don't believe it will work. Mm-hmm. Okay. I'm not exactly sure what is wrong here. Uh, But let me check one more thing. Not serve, not process. Okay. So I believe we won't be able to test this right now. But anyways, concluding, the code which we created here when I fixed it will be available under TokenGuard.io Azure ID repository. So you can follow along with the commands here written in the tutorial. And by the end of when you clone the repository and by the end of the launching process, SQD process should start the indexer. And then on the separate terminal, we can run SQD serve, which will present us with GraphQL Explorer. And that's, I believe, all that I can deliver right now. So yeah, I guess it's a wrap. In TokenGuard, thanks to Polka.Treasury, where we received the grant to further automate the process of creating the squids. We are building a solution in which you will only need to provide the API to our TokenGuard application, and we will generate all the required code for all the functions and events in your contract and deploy it for you. So you will be able to query the information about your contract directly within our app, just in a matter of minutes. And then later on, you can also you will be able to set up the conversions and filters which are interesting to use. So you will just select how that it important for you is how many times the domain changed hands. You will set up the pipeline like this, and we will provide you with the information and insights about your or others' application. So stay tuned, and in the next 2 or 3 months, that should be delivered and ready to use on our app TokenGuard.io. So I guess that's it. Thank you very much.
Jakub, there are two questions.
Yeah, right. Can you please characterize once again the purpose of the presented product? So in Web3, we're creating a lot of stuff, but this is what we discovered after talking with our customers. So we pretty rarely track what actually users are doing within our application, or what our users are doing in applications, what our users are doing outside our application. So the idea of TokenGuard is to provide information on exactly this. So what are the functions that users are using within your app, and what are the users doing outside your app, so you can target them and create marketing funnels known from Web2 e-commerce. And if you're asking about the purpose of the subsquid indexer, it is to extract from the blockchain data information that is suited for your use case. So in single processor, you can extract information about 1, 2, or 50 contracts and have it at hand within one simple GraphQL interface. Another question from Frank D. Rolf. So I send a squid to TokenGuard, and then I get a front end. I didn't get it fully. So can you elaborate again? You don't send the squid. You send your API, and we deploy the squid for you, and you get a front end through which you can first of all view your data on charts or numbers regarding the users. This is one functionality, and we with the grant we take it one step further, where you can similarly to how you set up conversions on Google Analytics, where you say that if user did A and then also did B, then we assign a cohort of type of users, segments of the users to this group of users. So we want to provide you with the interface to funnel your users, the users of your application in pretty similar way. So if you're interested in how many times Azure ID domain changed hand, or which domains are the domains that were registered and never used, you can set out the pipeline and access the information about this purely through the front end without the requirement to know and have any coding experience. Bitspresso. So are you relying on only Subsquid at the moment? Yes. Okay, one more question from KS. Thank you very much for the comment. So what user is doing outside the app? Is it about what the user is doing over the internet, or specifically outside the app? So there are solutions which are being built to do kind of cookie matching between user activity in Web2 and on-chain activity, mapping the user addresses with their Web2 activity. Spindle, for instance, is doing something like this, but we are not doing that. We at this point in time, we are purely focusing on on-chain data. So we can tell you what your user is doing outside your application within your blockchain or other blockchains which we support, as long as it is as the assumption that he uses the same wallet, even if encoding, basically the private key is the same, then we can map that user. If the user is deliberately changing his wallets, then we have no way to match and track user behaviors. But as long as he's using one single wallet along multiple blockchains, then we can provide that information about activity outside your app.
Okay, thank you, Jakub.